Hello everybody, this is Mr. Farley, and I'm going to do a few examples for you. And the first example I'm going to work all the way through. The second example I'm going to work part of the way through. And then the third example you're going to work all the way through. So let's get started. Let me get this out of the way. There we go. So the problem we're going to do right now is you throw a rock off a cliff and it takes 2 seconds before hitting the water. How high was the cliff? So the equation that we're going to use is the one that we're familiar with. Delta x equals 1/2 at squared, where this is distance, acceleration, and this is going to be the acceleration of gravity, so that's going to be g, which is 9.8 meters per second squared, and we're going to approximate that to be 10 meters per second squared just to make our math life easier. And then the t here, that's going to be time. All right, so if you look at the question, we have you throw a rock off a cliff and it takes 2 seconds. 2 seconds there, that is time. So I'm just writing down what we're given in the problem here. T equals 2 seconds. All right? And now it hits the water. How high was the cliff? How high? That's a distance. So that's going to be our delta x. And we don't know what that is. So I'm just going to put a question mark. Our acceleration, again, that is g, which we're going to approximate to 10 meters per second. Here we go. All right. And we have everything we need in order now to calculate this delta x. We of course can calculate 1/2. We know what a is, we know what t is. We're just going to plug that in now. Delta x equals 1/2 10 meters per second squared times 2 seconds squared. All right, so remember that's 2 seconds squared. And that's going to leave us, let me erase some of my water here. And that's going to leave us with 1/2 times 10 times 4. And that leaves us with 20 meters. Now I got the 20 meters because we have seconds squared right here, seconds squared, and we have seconds squared right here. Those two are going to cancel out each other out, and I'm going to be left with meters. And so meters is my units. And of course, meters is a unit of distance, which is what we're calculating. So 20 meters, that's our answer. Moving on to the next problem. An apple falls from a tree and it takes 0.5 seconds to hit the ground. How high off the ground was the apple before it fell? All right, so this is the same problem, just a different scenario here. So same equation, delta x equals 1/2 at squared. And what we have in the problem is t again, which is now going to be 0.5 seconds. And we have delta x, which we don't know. And we have acceleration, which is g, which is 10 meters per second squared. All right? So now, plugging it in to the equation, plug in what we know right here into the equation, we're going to get delta x equals 1/2 times 10 meters per second squared times 0.5 seconds squared. All right, now what I want you to do is calculate that. Pause the video, calculate that. Okay, so now if you're ready to know the answer, we're going to start with this one right here. We're going to go 0.5 squared. I always do whatever's squared first. So this is 0.5, and I'm going to square it. All right, that gives me 0.25. I'm now going to just multiply by 10 and then divide by 2. So I'm going to go times 10 and then divide by 2. Click equal. I get 1.25. That should be what you got. If you didn't, please try it again. All right, the answer is 1.25 meters. Don't forget your units. Again, seconds squared, cancel out. I'm left with meters. All right, and that's what I should be left with because I'm looking for a distance. All right, how high? How high? All right, now on to the next problem. You're going to work most of this one. All right, a suitcase drops from an airplane, takes 3 seconds to reach the ground. How high was the airplane? Okay, delta x, again, equals 1/2 at squared. All right, write down what you got. We have t equals 3 seconds. We have acceleration equals g equals 10 meters per second squared. And delta x, that's what we want to find. Okay, find it, pause the video, come back when you have an answer. All right, you got an answer? Did you get 45 meters? If so, you got it right. If not, I'll calculate it for you. Let me get rid of that. All right, delta x equals 1/2 10 times 3 squared. Okay, this is going to be 9, so we have 1/2 10 times 9, and that's going to be equal 45. The units, we know they're meters. We've done it a couple times. We can just put that there. All right, I got one more question for you to answer, all on your own. All right, right here. You drop a coin out of your pocket, and it takes 0.27 seconds for it to reach the floor. How high was your pocket? Okay, go ahead and pause the video, calculate it. All right, you calculated it. Okay, did you get 0.36 meters? If so, you're right. All right, that's it.